All right, so we're going to go through an example of how to solve our system with matrices. So I've got a system here that we're going to be working with. Now, our first step is always just to double check that our system is set and ready for this, meaning that everything is in standard form. So when I look at this, all the variables are on one side, constants are on the other, I know we're good. So I get to skip on to step number 2, which is rewriting the system as a matrix equation. Now there are 3 pieces that need to go into our matrix equations. We have a coefficient matrix, a variable matrix, and then a constant matrix. Now, based on those names, we can probably figure out where in the equations we're going to be able to find these pieces of information. So the first one, the coefficient matrix, is going to come from all of these coefficients. So all of those numbers that are in front of our variable. Now the nice part is with everything in standard form, it's already essentially arranged for us in a matrix. We just need to recopy it. So I'm going to copy each of my numbers, making sure that when I don't have a number in front, I know that's a case of the invisible 1. And when I have a negative, so either just a negative number or subtraction like this, that negative is going to have to come with me. So I'm going to copy all 9 of those numbers, keeping them in the same order, just all in one matrix. So that's our coefficient matrix. Next comes the variable matrix. This one's super easy. We take the 3 to however many variables we have, and we just stack them on top of each other. So we have x, y, and then z. Now our last matrix is our constant matrix, and that's going to use the only piece of the equations we haven't touched yet, those 3 answers, or the constant pieces. So we'll have 11, 13, and then negative 10. So that's our step number 2, get that matrix equation. So I'll label that for us. So that's what we have to do. Now we can actually be starting to think about using the matrix process to be able to solve this system. Now at this point, I like to throw everything into my calculator because I know I'm going to eventually need it all. Now, I stay consistent with what I put where in my calculator because then the last steps of this process are always going to be the same. So what I do is my coefficient matrix, I plug into my calculator always as matrix A, meaning that if I'm going to my matrix menu and I want to be editing, if I go over to edit, I'm always going to put it as matrix 1, so matrix A, which I've already done to save us time. So I'll cancel out of that. Now the other matrix we're going to need in our calculator is our second matrix, that constant matrix. And I always plug that one in as matrix B. So again, when I go to matrix, over to my edit, I'm going to make B that matrix that I have there. So 11, 13, and it looks like I missed a negative. So we need negative 10. Now everything's in my calculator, everything's ready to go to keep moving on. Now the next thing that we need is we are going to try to undo this side of the equation because our end goal is to get our variables by itself. So we need to undo this matrix by using its inverse. So we have to, for step number 3, find the inverse of your coefficient matrix. Now luckily, we have our calculators to do this for us, so it's going to do all of the thinking. So remember, to find the inverse on our calculator, we need to pull up the matrix we're working with. So I'm going to go to my matrix menu, use A since that's where I put it, and then I want this inverse button. So we're going to use that negative 1, and we get a really messy inverse. Now remember using the math button, and then fraction. Suddenly we get something that's a little nicer to work with. So I can now, that we can actually see it, know that this is the inverse that I'm going to need. Now what I have to do with that inverse is multiply it with this, because that's how I'm going to be able to undo what's happened so far. Now it's important that I multiply it on the left side, because that's what we're going to have later on for dimensions to work. So I'm going to take that matrix, that inverse that I just found, and I'm going to copy all of the pieces. So 3/20, negative 1/20, negative 1/20, all the way through all 9 pieces of this. right, so there's my inverse. And I said that I am left multiplying it, meaning that it needs to go first in the equation. So I need to copy all my other pieces. This is how I show my work for these problems. Since our calculator is doing all of the thinking for us, the least we can do is keep track of its thinking and write it all down. Now we're solving an equation here. So I can't just multiply one side by this matrix and not expect things to get totally changed up. I have to keep everything balanced. So because I multiplied on this side of the equation, I have to multiply on the other side of the equation as well. So again, we need that inverse. So I'm going to copy all of those pieces because I need to make sure that I'm showing my work. Only this time we're just multiplying it with the one other matrix on that side. So we have 11, 13, and negative 10. All right. So at this point, I'll fold it so we can actually see what's going on. Now we're at the point of some multiplication. Now the left side of this equation, we know what's going to happen. Because whenever I take a matrix times its inverse, I know my answer is always, always, always going to end up being the identity matrix. That's the definition of inverse. That's the whole point of it. Think about numbers. If I'm taking 4 and I multiply it by its inverse times 1/4, I end up with 1. 1's the identity. That's exactly what's happening here. We're undoing this matrix with its inverse to essentially end up with 1 times our variables. It just looks fancier because it's matrices, but this is no different than ending up at a point like that when we're solving with just 1x. We know that's when we get our answer. So that side's fine. It's this side that we're going to have to actually do some work for. Now, if we put everything into our calculator the way that I always do, I always am doing the exact same thing on this side to get my answer. I'm taking the inverse of A and multiplying it by my matrix B. If you always put your coefficient matrix in A and your constant matrix in B, this is always what you are going to be doing to get this answer on the other side. So when I do that on my calculator, I know that I have to pull up my matrix menu, and I need A. I need the inverse of A. But now I don't just want that. I need to pull up my matrix menu again and multiply it by B. Notice what I've got in my calculator is exactly what I've got on my paper. A negative 1B. Press enter, and you've got yourself an answer. So 1.5, negative 5, and 2. Now, this identity matrix really doesn't mean anything to us. Like I said, it's the same thing as 1 times x. And when we're solving equations, we ignore that 1. So I can pretty much ignore this and just focus on my answers. Notice that x, y, and z all match up to a number. That's telling me what my answers are. I know that x is going to be equal to 1.5, y is equal to negative 5, and z is equal to 2. But I don't want to put my answer like this because we're solving a system. We know how our answer should be. We're going to list it as a coordinate point. And yes, it's okay that we have 3 pieces of a coordinate point. You just list them in order. It's actually a 3-dimensional coordinate point. So something that you don't see until college math, but we can still express our answers this way. So those are all of the steps that we want to be following every time I ask you to solve a system. We want to rewrite that system, get our matrix equation, then our calculator does the rest for us. The calculator will find the inverse for us. We need to multiply that on both sides. One side's easy, it'll just turn into the inverse. The other side, a little bit of calculator work with that A negative 1B is how we're going to be able to get our answer out. As long as you put your answer as a coordinate point, you're going to have a completed problem.